Hello everyone. So in this video, we are going to solve merge sorted array. So you are given two integer array nums1 and nums2 sorted in non-decreasing order and two integers m and n representing the number of elements in nums1 and nums2 respectively. Now what we have to do is we have to merge nums1 and nums2 into a single sorted array in non-decreasing order, that is increasing order. The final sorted array should not be returned by the function but instead be stored inside the array nums1. And now to accommodate this, nums1 has a length of m plus n, whereas the first m elements denote the elements that should be merged and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. So here nums1 has a length of m plus n and nums2 has a length of n, and we have to move these n elements from nums2 to nums1 and in the increasing order. Now let's see example 1. So in the example 1 we have 6 elements, that is m plus n, and we have to move these 2, 5, 6 inside the nums1 such that the resulting array will be in the increasing order. So this is nums1 which has 1, 2, 2, 3, 5, 6. In the example 2, nums2 is empty, n is 0, m is 1. So the nums1 is of length m plus n, that is 1. So the final resulting array will be this. In the example 3, nums1 has a length of 0. The actual length will be m plus n, that is 1, and nums2 has a length of n. So let's see how are we going to solve this. Okay, so we are given these two arrays nums1 and nums2. Now what we have to do is we have to move these elements inside these array. So this will be nums1. So 1, 2, 3, 0, 0 and 0. So what we have to do is we have to put two pointers. So the first pointer will be at the end of the nums1 and the second will be at the end of the nums2. So you can see that the nums1 has a length of 3. The actual length will be 6, that is m plus n. But the m is 3, which means there are 3 elements that we have to take into consideration while merging. So we have to put the pointers at the end of their respective arrays. So here we have pointer at 6 and we have pointer at 3. Now we have to move the elements from the nums2 inside nums1 such that the resulting array will be in the increasing order. So why we have put the pointers at the end? Because if we put the pointers at the end, we will be able to get the maximum elements every time, and by doing so we will put the maximum elements at the end of the nums1. So the final resulting array, the nums1, will be in the increasing order. Okay, so first we will compare 3 and 6. So which one is bigger? So we will take 6. So we'll put the 6 inside the nums1 at the end. Now we will move the pointer behind. Okay, so now 3 and 5, which one is bigger? That is 5. So we'll put 5 at the end. Now we'll move the pointer behind. Okay, now 3 and 2, which one is bigger? So it is 3. Okay, now we will move the pointer behind. 2 and 2, which one is bigger? We can take either one. So let's take from nums1. So we'll write 2 here and move the pointer behind. Now 1 and 2, which one is bigger? That is 2. So we'll write 2 here and move the pointer behind. So at this position, our pointer in the nums2 is outside the range. Okay, which means that we have moved all the elements from the nums2 inside the nums1. Okay, so we don't have any elements to move inside nums1, so we can quit the execution here. Pointer here at the 1, but this doesn't matter because what was our requirement was that we have to move the elements in the nums2 inside the elements in the nums1, and we have moved all the elements from nums2 in nums1 and in the increasing order. So the final resulting array is 1, 2, 2, 3, 5 and 6. Okay, so example 2 is not of that relevance because it has only a single element, but let's see. So in that nums1 has one element and nums2 has no element. So here the pointer will be at the end of the nums2 and nums1. So here the pointer will be here, and here since there is no element, the pointer will be here, which means that we have moved all the elements from the nums2 inside the nums1. So eventually we will return only nums1, this only. So there is no execution here. In the example 3, we have nums1 as this and nums2 as this. Here the pointer will be here, and in this case the pointer will be here. Sorry, not here. Here it will be. The pointer will be outside the range, and here the pointer will be at the 1. So now we will compare the elements at the two pointers. Since this pointer is outside the range and this is inside the range, we'll take this into consideration and we will write 1 here. And now the pointer in the nums2 will be outside the range and we will return this array. So now let's write the code. So first thing is fill index. This will be m plus n minus 1. So this will be the end of the nums1. So here it will be this one. So this is the last index of nums1. So we will start filling our elements from this index. Okay. Now, while there is either m or n, which is the sizes of these elements. So if n becomes 0, we will quit this while loop, else we will continue. Okay. So let's say first we will take elements from the first array, that is end of the that is in the nums1. We will use this element and this element, that is nums1. We will take m minus 1. Okay. And the second element will be this, that is nums2, and that is n minus 1. But there is a problem here. Let's discuss that later. So we got the two element. Now we'll take the maximum of these elements, that is max of s1 and s2. And now we will, in the nums1, at the fill index, we will set this element mx. And after setting this element, we will reduce the fill index. And finally, we will check if this maximum element was s1, which means we have used the element from the m, that is from the nums1, which means we have to move the pointer behind, which means we have to decrease m, else we have to decrease n. Now the problem here is, what if n becomes 0 or m becomes 0? So if n minus 1 is 0, which means s2 will be the first element in the second array. So this one. Okay. And now let's suppose that mx we have assigned here only. Okay, the last element somewhere in this nums1, and we checked that max is not equal to s1, which means n is now reduced. So if n is 0 here and we have used n in this iteration, which means we have assigned that s2 inside this, which means s2 is used, and the next time n minus 1, which means n minus 1 is 0 here, which means in the next iteration it will be minus 1, right? Which we don't want. So if n is less than 0, then we can quit early. Okay, so what I'm trying to say is, if n is not there, then we can return early, or we can say that there must be both m and n. So in this case, let's see the result of this first. So last test case has been failed. So we have nums1 is 0 and nums2 as 1. So first we'll check if m and n. In this case, there will be no m, but there is n. So we cannot use and here. We'll have to use or only. And now we don't have m here since m is 0. So 0 minus 1 is minus 1, and that index does not exist. So what we have to do is, we'll have to check that if m minus 1 is greater than equal to 0, then only take this, else we will take int min. Similarly, if n minus 1 is greater than equal to 0, then we will take this, else we will take int min. Either s1 or s2, either one of them will be there. So we'll take the maximum of that, and the maximum will obviously be the value inside these nums1 or nums2. We will take that value and assign it. Now if we have assigned all the elements from the nums2, then we can quit early. So we'll check if n is 0, which means we have used that is n minus 1, that is n minus 1, here it will be used n minus 1, that is n is 1, so 1 minus 1 is 0. Now here if n is reduced, when will n will be reduced? It will be reduced if the current value that we have used is s2. Okay, then n will be reduced and n will become 0. And the next time n will be n minus 1, that is minus 1. But since n is 0 here, we are sure that in the current iteration, the last value of s2 is used and mx used is s2, right? If this is the condition, then we can return early. Let's see the result of this. Now we will submit to verify this. And our solution got accepted. So what we did is we took the value from the S1, we took the value from the S2, we took the maximum of that and assigned at the fill index. And after setting this value at the fill index, we'll reduce the fill index. Now we will check which value of mx we have used. If this was from the S1, we'll reduce m. If it is from S2, then we will reduce n. Now we will check if n is 0, which means that we have used all the values in the S2 and moved that into the S1, that is nums1, then we can quit early, and that's what we did.